meeting. And welcome everybody to the Knative Community Meetup, and welcome to 2021. My name is Maria Cruz. I'm a program manager in the Google Open Source Program Office. And we are going to go ahead and get started. For those of you who are just rolling into this meeting, here's the agenda. We have a few announcements today. So let's go. Oh, am I sending this to everybody? No, here. Okay, sorry about that. Now you should have the agenda on the chat box. Let me see. We have some announcements from the operations working group. Any members of that group that are here in the call?
Yes, yes, this is Vincent. I am working as a lead of operation work group. And the announcement is about the feature customized manifest. I think in the new release 0.20, it's a kind of improvement with this new release. We all know that operator CR cannot configure everything. So when actually we ask the question that, hey, whether I can use operator to configure this or that, I say, if not, what we can do as an alternative is to use a kind of customized manifest to actually install any other kind of resources available into your cluster. With this feature, we're only able to overwrite all of them at one time. But with this new feature improvement, we are able to overwrite partially some of them. And you can choose either use the overwrite mode or the append mode, depending on what your needs are. And we either overwrite all the resources or just partially some of them, or add some new ones. And documentations are available here as I posted these two links over here and in the agenda. They are part of the official documents of operator. So give it a try. Not perfect, but yeah, you can definitely give it a try. Hey, thanks.
Thank you, and I'm sorry about my cat yelling. I think we have more updates, maybe from Carlos. Is that you that added user experience interviews, or?
Yeah, I added that. Just 2 minutes. Can I share my screen?
Yes,
for the
please
2
do.
minutes? Just a quick. If I can share, I don't know. Disable participant screen.
Let me make you a co-host real quick. 1 second, sorry. Why can't I do this? 1 second. Do you want to send me, do you have a link that I can share? Maybe I can share it for you.
That's okay. I'll paste a picture of what I wanted to show in the chat when I'm done. But the announcement is that myself and Omer Benson, we are asking folks in the community to see if they can donate probably 40 minutes to an hour of their time to do user interviews in terms of user experience. And we have been doing, so far we have been doing, I think around 5 of them, 5 or 6. And the idea is, and I was going to show, I'll show a picture of what a preview, but we're working with design thinking and sticky notes and ideation and doing findings out of the interview. So if you can contact myself, Carlos Santana, or Omer on Slack, either if you are getting started with Knative or if you want to provide feedback in terms of if you're in the next stage of using it and trying to get in production, to understand better the user needs, and basically that will make it into improving the experience that people use with Knative, either getting started, improving the docs, changing the docs, providing a quick way of getting Knative installed on your local machine, or a different way of explaining things, or maybe utilities and tools to help you get the best out of Knative and get started. So if you want to donate your time for this type of interviews, it's a quick interview, and we just ask a few questions and we take notes and we convert that into a board that we are analyzing now with some designers. So I'm going to show a picture of that in the chat. That's all.
That's really that's an awesome project. So the call to action for people to participate would be to get in touch with you, or
yeah,
with
with
someone.
me. Yeah, Omer or myself. There's a Slack channel called User-Experience, and we also are working on a proposal for a new working group around these utilities, tools, user experience type of things. So you're welcome to join in that Slack channel.
Great. I'm copying the link to the Slack channel here. I think I got it right. Great. Thank you very much. And I think.
Can
Oh,
sorry,
yeah,
I don't
please.
want to interrupt.
Go ahead.
But I couldn't find the I'm a polite person. I'll raise my hand, so I'll just interrupt. I looked. But what Carlos said is exactly true. But I would also like to highlight that even if you don't want to go ahead and participate in those interviews, you might want to be interested in joining the UX working group, because it's a cross-cutting area. So we definitely want to go ahead and encourage folks to come and hang out there as well.
Yeah, +1. I think this is a really important area for us to grow in, especially that initial experience to drive adoption this year. So if you have some time to help contribute, it's really appreciated.
Great. Thank you so much. And I think that will lead us. Oh, we have an announcement from the event. Oh, Vincent, did you add an announcement from eventing working group?
That was me.
Okay.
So I just wanted to quickly share that we are working on the roadmap. We kicked off a series of meetings for the roadmap for the different eventing working groups, eventing event sources, and eventing delivery. And you'll see the link in the notes for the roadmap doc. The idea there is once we finalize with an initial version of the roadmap, it will be present as a markdown file on the repo of eventing, and it's kind of gonna stay as the living roadmap that we present for the TOC from. So feel free to engage there with your items. We basically differentiate between roadmap items that have folks who are working on it, and there are people who are driving it, and kind of like wish list, or we call it icebox items, where it would be nice to have that, but we're still looking for people to drive it. So feel free to also look into the icebox items if you want to pick one of those items out. We'll try to present again once the whole roadmap is finalized and merged up on the repo. Thanks.
Thank you. I think a few people were having trouble hearing you, but were you saying that you would like feedback on the link that you shared on the notes?
Yes. Are you able to hear me better now?
Yes.
Oh, sorry about that. That was probably the wrong mic. Yeah, basically I'm saying, please try to look into the roadmap and feel free to add items there. We kicked off a series of meetings, and there are two kind of items, ones that have people who are already dedicated to work on it or willing to work on, and items that are kind of like a wish list or icebox items. And these basically have no people to work on. It would be good if folks from the community look at the icebox items and maybe if they want to pick up one of these items and write them, that would be great. We will present again on the probably next community meeting, hopefully the final version of the roadmap. Thanks.
Perfect. So I think that if there are no more announcements, we're going to move on to the demo. And PJ, the floor is yours.
Okay, thank you. Great, I'll just try and share my screen. I've managed to never use Zoom before, which is quite an incredible achievement these days, but let me just check. I've just got to give permissions. I'll just hop out and hop back in one moment. Okay, can you still hear me?
Yes.
Perfect. And can you see my screen?
Yes.
Okay. So I'll apologize firstly because this deck is pretty much shared from conference to conference at the moment. I haven't really had time to update it, but I'll try and extrapolate the specific Knative elements as I go through, so I'm not boring you with too many superfluous components. So I've called this Taking AI to the Edge because predominantly it's focusing on how I've moved some of the machine learning components in this solution I'll cover onto edge devices. But a lot of the pipeline is both cloud and edge based, so I want to cover how those two things differ in this particular solution. And this is an 11-year-old project, or almost 11 years this year. And originally was started as a hobby project and is now a large commercial project. So I'll cover some of that evolution as I go through as well. But this means that a lot of the components are not consistent throughout this solution. But I'll try and talk about some of the difficulties of how that technology roadmap has evolved as we've gone through as well. But when it comes to things like Knative, those elements are fairly new in comparison to other elements, so that they're not used throughout this solution. I've said adding ML to coffee here because it's actually a agricultural project specifically focused on the coffee industry. So the case that I had originally was to build a sustainable agricultural product. And again, as a hobby project before it kind of got out of hand. So it focused on urban farming and rural farming, predominantly in Kenya originally, but now across Africa and South America. Around 60,000 farms, I think, run on the platform. It focuses on coffee production only, but that was meant as a case study. It's actually the components now run on forestry solutions as well to do sustainable forestries and other food areas as well, but not predominantly with the same core components. So the idea is to track coffee production from the origin all the way through to the cup and make sure that it's sustainable throughout and make sure that it's both sustainable ecologically and economically. So covering both of those elements. So that means understanding the market data and understanding the environmental data as well. So using predictions from weather systems and commodity markets and trading markets to advise the farm producers and the retailers on what they need to do to make it more sustainable. So the challenges were low cost delivery. I didn't want to pass on any costs to farmers. And I also wanted to make sure that I could afford to build it in the first place. Low connectivity services. So we had 2G and below. Sometimes it was just simply 1G to get the connectivity. So we were using SMS data essentially to send data up from the farms. So those pipelines had to be efficient. I say a small team on the next point, but essentially it was just me for at least 5 or 6 years. And then it was multiple complementary teams that helped me get there from different companies. And then multi-region. So again, I've said before, it goes across borders, across Africa and South America and Europe. And then I've used the term self-sovereignty here. So for those that aren't aware of the term, it's just essentially giving everybody the ownership of their data here. So that was quite a technical obstacle to actually getting this rolled out, because we wanted to make sure that the data wasn't centralized and none of the actual software was centralized. So the way we rolled out software had to mean that people could own that pipeline themselves as well. So starting off with the farm, we had the original MIST. When I talk about MIST, I mean the sensors, and we also had automated machinery and drones. We rolled out custom software to those devices. And we had different partners at different stages. So I think in 2015 or 2016, NVIDIA helped out with some drones. Otherwise, we couldn't have done that. And we did the machine learning on board the drones, so we didn't have to take that data afterwards. So it was fully automated. And then we had sensors picking up things like moisture, lighting, and different weather effects like wind as well, just to see what the effect would be on crops. And with the drones, we did spectrographic analysis, so we could scan the crops by flying drones over and then taking imagery and then working out what looked healthy and what didn't. And that's what we're using in the forestry solutions now, in large forestry solutions in Canada and the Nordics. So we scan the forests and then read the data and figure out how healthy the forests actually are. So that's the MIST. The fog is the components that aggregate in different regions. So typically one farm could span quite a large landmass, and then it'd have multiple MISTs, and then the fog would aggregate that data. So we didn't needlessly send data to the cloud. So we had quite a few different gateways. We had control management systems there, so you could manage the system with your SMS messages, data processing. We had ETL for data transformations locally, so we didn't send superfluous data up. And then we had machine learning inference locally, so we could figure out how to operate the machinery, but also how to advise the producers on the ground what to do in case we were predicting bad weather effects or we're predicting significant market changes. And a lot of these components are fairly off-the-shelf components, but we worked with ARM and IBM to provision a lot of the hardware to make it easier. So this is holistically what a single farm would look like. At a very simple high level, we have the neural processing units. So NVIDIA provided us with a lot of hardware for that. Anticipation control to actually control the devices using SMS. We used Apache Kafka to do aggregation of the data, and Spark to do the ETL or ELT. And we used LoRaWAN gateways across different farms to aggregate that data from the different devices, including landing areas for the drones. So the fog management was Pelion. It was originally owned by ARM, but Pelion did, because it had to be multi-cloud for the farms, because there's a self-sovereignty issue, Pelion was used to do the device management rather than using something like Azure IoT Hub or AWS's IoT management software. Used custom Yocto builds for the implementations, and then K3S orchestration over the top of that on the fog platforms. The MIST platforms had lower level software, but the fog platforms used K3S orchestration both from the cloud through to the edge devices, and that was provisioned predominantly manually in the beginning, and then using Pelion, and then eventually using an automated pipeline, which I'll cover in a moment. And then on each fog, we had a custom low-level update manager that was written in Rust as well, just to ensure that we could replace the orchestration layer if need be. And we worked with ARM on that software. So I'm going to focus on the data platform. There's a lot of other components within this solution. There's mobile apps, web apps, different interface and integration components as well, but that would take far too long to go over. And I don't think I could keep everyone's attention for that long. So I'll focus on the data platform for now. And that's where the pipelines are the most interesting, I think. So for the ingest, used Kafka for data streaming, used Flink for the aggregation, Spark for the processing, and then Hadoop over HDFS and Lustre for storage. So that was high performance storage of data. Each ingest area for the cloud, because there was multiple ingests, would be handling around 320 terabytes of data a month on average. So we had to ensure that the file system itself was high performance in that solution. And then a data lake I built. Again, it had to be cross-platform. A lot of cloud providers provide their own, but this was a generic portable one that anybody else could own if they wanted to reload this solution up and manage it on their own farm. So it's fairly standard components and fairly relevant to the conversation, but I'll just go over quickly that we used Airflow for the orchestration of the pipeline for the data, Apache Atlas for governance, Spark for the ETL, and Apache Ranger for security. And then there was Amundsen's data catalog for actually listing the data and allowing it to be queryable by other sources. So the data lake was singular and central physically, but conceptually it could be managed by multiple teams with their own governance and their own security protocols. And this has been reused on multiple solutions since I built this for this project. It's kind of the same components. And again, solutions like the forestry solution, and we're using a lot of these components in medical solutions as well. So like medical equipment, where we can censor what's happening with a certain piece of medical equipment in the hospital. It goes through the same pipeline as this, and same analysis layer as well. And then separated the data lake into a data mesh. So what I mean by that is technically it's very similar, but we separated the teams into multidisciplinary teams. So the data scientists were not separated into their own containers. They worked with the development teams into functional product teams instead. So they would develop with the development teams on an end-to-end solution for every data ingest that came in. So every source, like for example, lighting data or moisture data, that would be a product, and we'd build a service based on that. So we'd build a batch service and a standard REST or GraphQL web service as well based on that. So it would be managed by the same group of people, and that allowed a different focus and set of priorities depending on who I was working with in scaling this solution up. And then each product is served to the lake, and it also can be served to third-party components as well, like mobile apps or web apps. And then the governance is distributed. So as I mentioned previously, we use Apache Atlas for distributed governance, but the data could be centralized. So it's physically how it works is different from how the teams operate. The teams are decentralized, but the storage can be centralized. So the policies were managed centrally as well, and it was important to manage those policies in a ubiquitous way because the complexity of this is quite high. And then this is specific to the mapping solutions. We had to do a lot of augmenting of the data indexing. Again, it's irrelevant to the Knative, but it's worth going over that there was a lot of custom mapping solutions that were worked on to get the indexing and performance up on managing that much data. So the business intelligence was the bit that made most organizations interested in this solution. So that was all about providing pretty graphs and reporting. So there's a lot of different components in there that made that happen. A lot of the companies we worked with were using things like Power BI, which is quite ubiquitous in a lot of organizations. We needed something that could roll out in each organization independent of what kind of cloud provider they were with or what hardware they were using. So again, Kafka and Spark were there. We used Druid for the time series and real-time data, and Killing for historical data. And most of these are Apache projects, and they're quite proven in this kind of space. So it's been very easy to get them to roll out. But the rollout originally was very manual to get all of this to work. And then Redash used for the actual dashboard and Superset as well for the real-time dashboards. Added a few extra things at the end of what I started adding last year to this solution, which is Pinot for new data. We're still reviewing that. And then Presto for data querying. So that's the Facebook aggregation for data querying. And then the data science element. So this is where the research happens. So a lot of this is hypothesis-driven development. A lot of the machine learning to do the predictive intelligence is based on ideas and concepts that aren't proven. So we need the data scientists to be able to look at that data in a safe way without any of the data getting leaked. So we create a secure data science pocket that comes through the same data lake, and then they can experiment with that data without actually having access to that data. So they go through the same catalog, but there's a set of policies in the governance to prevent them doing anything else with the data. And then once they've done a model or report, then they can put that into a pipeline and then ship it to either the BI tool if it's a report, or they can ship it to the edge network or the cloud intelligence services if they want to actually render that model in a solution somewhere. And that is automated as well, so the actual pipeline deployments are. So this is where it actually gets interesting, where we start looking at those pipelines of how everything gets built and deployed. So one of the things I did differently to most client projects I work on, typically they use something like Terraform. I don't, if I can get away with it. So I didn't on this project. I had free range to do whatever I wanted. So I created a custom cloud bootloader, and this bootloader would load up any cloud provider that was supported on this. So we did the big 3, and we also supported Red Hats and Alibaba as well, and DigitalOcean as well from the offset. And then we supported custom hardware if somebody wanted to install any of these components on their own infrastructure. So that custom bootloader was written in Rust and Go, a combination of both. Go for the CDK and SDKs for the cloud provider, and Rust for the actual runtime. And then it was event-based. So rather than things like Terraform, which are configuration-based for deployments, this, you could tell it how to react to different events happening within the cloud infrastructure, or even on the boot, to be reactive and make additional changes to the infrastructure. We actually added machine learning to this component as well, so it could actually react based on what it had learned to do on to scale infrastructure appropriately. And this is essentially a single-click application. So you double-click once you've given it the config of where the hardware is in terms of the network, and it will copy itself onto that network and build it, and also secure it. So it will create the firewalls and lock down the SSH port, so nobody can physically get onto that infrastructure once it's built. And then it just destroys and rebuilds itself over time. So the CDKs and SDKs are already provided by the cloud providers. And then it's stateless and reusable. So if you run it again, it will just look at things like DNS settings and figure out what the current infrastructure looks like and destroy and rebuild what it needs to each time. So that's for the end users to use in terms of the customers, the producers, the farms, or the importers. So actually building the clusters, originally I did this manually and wrote a lot of code. I spent a stupid amount of time writing code over and over again. And then eventually I moved over to using Argo CD for getting the clusters up. Because I could just do the configuration once using Customize and throwing some Helm configs over, and it would build that infrastructure for me. And that would bring it from Git originally, but that's something I tried to avoid. So I didn't want to drive the infrastructure from Git. I wanted to drive it from the bootloader. So the bootloader would say what infrastructure needs to happen, regardless of what's happening in Git. It would just pull it out of Git when it decides it needs to. But essentially Argo CD, which is what I'm using at this point, is GitOps driven. And then it separates the configurations from the code. So I could just say, hey, here's an Argo CD deployment, which is the first thing I did. I launched 2 components with this. So I launched a authentication component and then Argo CD, and that was essentially my pipeline up and running. And then once Argo CD is up, it would build the rest of the infrastructure, and the code would manage how that looks. And then this could be configuration driven after that. So this only happened beginning of last year or the year before, I think 2019. I put Argo CD in experimentally, but it's scaling up at the moment. So the cluster architecture now looks like, this is a very simple overview, but this is zero trust architecture. So we have an authentication system across the entire environment. And again, you can, when you're on auth layers, on its OAuth 2 and OIDC. There's standard components that we have Istio for the cloud-based clusters. There's clusters on the edge devices, but I won't go into detail on those. They're not that different, apart from we're not running Istio on the edge devices due to memory issues originally. And then we have Prometheus for logging, and then we have, because it's Envoy-based, we use WebAssembly custom extensions to the actual HTTP traffic. So we handle the HTTP and UDP traffic using WebAssembly extensions, and then that ports through on each of the service nodes. We push it through to a Knative deployment. So that workload service function component you can see there, that's essentially a Knative component. And then we used NATS for doing the event queuing. And there's cloud events throughout this architecture as well for how things communicate with each other. This was a sample thing I sent to one of the partners we were working with to show them how we did the enterprise integration patterns. So that's why we've got EIB on the middle component there. But it's a fairly generic overview of our Knative cloud deployment for our clusters. They're all essentially the same, and they're decentralized and stateless. So we have Tekton now for building the services. So Tekton is essentially all about the CI. So we only use Argo for the CD and Tekton for the CI. And that begins with the Knative tasks. So from the code repository, we do the builds once, and then we could do multiple deployments from those builds. So we've separated CI and CD completely as two separate ideas. To simplify the amount of computation that's happening and reduce the amount of potential for errors. Using Helm throughout as well with a custom chart museum. And then when it gets to Tekton, there's a couple of different components that are managing security to keep the integrity of the builds high. So Notary and Falco are both used to manage the integrity of those images and the dependencies. And then it goes into container storage. So once the CI pipeline goes into container storage, it's fully tested and it's tagged, and we assume at that point that that image is perfectly usable. And we don't have to retest it when we go to a deployment. And then we do, there's a lot of canary deployments, blue-green deployments, and multiple version deployments at the same time that are managed in the cluster configs. So multiple versions can be live at the same time. So we want to make sure that they're still being tested for those dependencies and nothing goes stale. And then cloud events, as I said before, cloud events are used throughout. So cloud events are both used in the custom services, but they're also used in the pipeline as well for making sure that when something happens within a build or within the infrastructure, that we manage the provisioning dynamically based on those cloud events. And then, as I said, this integrity and security checks are part of the automated audit. And then there's a developer gateway. So that was simply a web-based generation. So using something like, I think it's Hugo for developing a static website from OpenAPI 3 and GraphQL documents, and then generating a documentation and deploying it with Redoc into a cluster environment. And then it uses the same zero trust OAuth layer to actually do the authentication after that. So you're still logging in through the same system to manage who has access rights to different services to actually develop against those. This is for both third-party and internal developers. And now for the building models, and so this is where it got a little bit complicated. Originally, we were doing a lot of this manually, so we're using a lot of NVIDIA hardware for doing massive model development and building, and then testing, which didn't really work. We were then doing manual deployment and having to go through Pelion for that as well, to deploy it to edge devices and mobile devices. And now web applications as well have models built in. So now it's driven by Tekton. So I took the same pipelines once I got them working with the service deployment, and then got it to continue that build through into Tekton, through Tekton into Kubeflow. So Tekton throws the process for building a model into Kubeflow. We use Feast for feature extraction and Knative for hyperparameter tuning. Use TensorFlow data validation to validate the data, then use TensorFlow for model training predominantly. There's a couple of other data science tools that we're using, but mostly it's TensorFlow. I've been using TensorFlow for quite a few years now, so it works well at this scale. And then we use TensorFlow model analysis to do the analysis of the model and make sure it's performing. So there's, in fact, in the ETL and in the models, model training, there's a lot of unit testing throughout. So that this isn't typical in the industry when you're doing data science projects, but it is something I've ensured that goes throughout this. So there's unit testing and model testing throughout to make sure that the integrity of the models are correct. And there's federation on these models as well. So this isn't a centralized machine learning system. This is a federated one where we deploy the models to the edge and even mobile devices, and they run there. They don't run in a central cloud environment that often. And then they federate their intelligence together dynamically. So they have to be tested rigorously to make sure that the results will be usable. And then they're deployed using TensorFlow serving on Knative as well. So TensorFlow serving is running on a Knative deployment, and then the models are deployed there with an API, and then they can be pulled down there, or they can be pulled down physically using TensorFlow Lite onto devices dynamically. So we can update mobile apps without replacing the app itself, just by pulling down the model. And we do that with the edge deployment as well. So the edge deployment, again, Pelion device management and Yocto, but when we're rolling out things, we're doing it with phased edge developments. So we can schedule what's happening. For example, if we pick Kenya as a region, we can say Kenya's getting an update next week, but the rest of the world's not going to get it for another month. And then it allows us to manage those rollouts a bit more effectively. Again, we use this process for rolling out deployments in medical projects and the forestry solutions as well, to make sure that we don't roll out everything at once, and we can test different regions, and we also can do rollbacks. So we can do region and customer in this case. There wasn't really a customer, but there is a customer in the medical solutions and the forestry solutions, so we had to be able to tag those separately as well and give them a specific version in the pipeline rollouts. And then we do increment versions with Canary and Semver 2 deployments, and we use those in the headers. So a lot of people will specifically set versions, for example, in the URLs for services. We use HTTP headers, so that's how I determine which version we should be directing traffic to on the actual clusters. And then the micro devices download the TF Lite models, and again the federators. So when the TF Lite models are on the devices, then the models learn on those devices and send their learnings, not data, back to the cloud. So it's entirely privacy aware. We're not actually sharing data from any organization. We're just sharing the learnings, and then the models are improved at that point and thrown back down. So this solution entirely from end to end is now, we have a cluster set up on day one with Argo CD, and then we have Tekton doing the CI builds throughout. And then that drives the versioning system, and then everything is Knative, including on the edge. The K3S deployment on the edge device is a Knative deployment as well, as of this year. Yep.
You have about 3 to 5 more minutes.
I'm done. That's thank you.
Thank you. Awesome. So we actually have a few questions for you. We can still see your screen.
Yeah,
we have a few questions for you on the chat box.
Sure.
So Alec is asking what choices were considered: performance, cost, trade-offs, what is budget, funding levels?
Okay, so the budget from day one in 2011 was 0. It was literally a hobby project, and that's how it got a little bit crazy. So in 2014, when it started to scale up, I realized that 0 budget doesn't work for what I was trying to do. We had about 113 components at that point. So the budget ended up going up to 6 figures. I think it was about 340,000 a year maintenance costs to run this, and that was funded by several big cloud companies. So yeah, about 340,000 a year, I'd say, is the current running costs for this. For the entire solution, for the data platform itself, we're looking around 6,000 or 7,000 a month, I think, minimum when it's scaled down on a kind of static level. So yeah, and the trade-offs and performance, most of the time we're looking at scaling resources more than scaling performance. So it was about how we could maintain this easily with a very small team. And that's why, in this case, Knative made sense, because building custom Kubernetes deployments, which is what I did originally. In fact, I didn't even use managed Kubernetes, was a nightmare. So it was about simplifying each layer to make the rollouts a lot easier to maintain and maintenance a lot simpler. Performance was easy to get right after that. Once we managed to get a maintenance cell that was manageable. Yes, so I can share the slides as well for like I said, the text is too small, that's fine. I can send those out, so you can look in those and I can send the images out.
Yeah, it would be great.
So yeah, I use the event broker and I use NatsQ, so there's a combination of both depending on times, but I try to use the eventing broker as much as possible. But there's multiple different things. We use other eventing systems as well. So there was, I can't remember, some more Apache tools, obviously, but there's also some tools from, we used Azure's Event Hub as well for some of the eventing at one point, unfortunately, due to dependencies before we had to pull that back out again. And what version of Knative is the latest, because I'm living on the edge, so I just keep pushing things as late as I can get. I think in some of the cloud environments, I'm using older versions due to the fact that the managed Kubernetes that comes pre-installed is an older version. And then the Knative, I wanted to make sure there's good compatibility with that. So there is a few variations in that, but most of the time I'll go with the latest version, the latest stable version. And occasionally I'll go with a night build. Sorry.
Can you read the question next time before you answer it, please?
Oh yes, sorry. Yeah. So that was just what version of Knative am I using. So anything particular about Knative serving and eventing that stand out on the edge? Not particularly. I think it solved a lot of problems I had with manual management of that. I think most of what stood out for me was actually getting the Kubernetes, because as I said, I'm using K3S, but using Kubernetes at all on edge devices was a difficult thing to manage with memory. So it was always how to get the edge devices to operate effectively. And a lot of the time, that's why I rolled into K3S. I used Kubernetes to begin with, and we couldn't get it to work. And I used Istio, and we couldn't get that to work. So we had to roll into using Linkerd on the edge devices for that reason. So yeah, I don't really notice anything to do with Knative serving and eventing, because it works well compared to all the other problems I've had going on to edge devices with the rest of the stack. And yes, there's a lot of cost savings. So with the Kubeflow thing in particular, tried MLflow as well. And I tried using the cloud native one. So I use Azure and AWS model building infrastructure for a lot of customer projects. And they seem really straightforward until you try and do anything custom or specific, where with KF serving and Kubeflow, it ended up resolving a lot of those conflicts and allowed me to take a custom build on one project. And now I've rolled it onto literally hundreds of projects and not had to rebuild it at all. So I'd say that's a huge cost saving for the client projects I'm working with. Do you think that's it for questions?
Yeah, do we have?
Oh, wait,
we have
there's one more.
Yeah.
So what does Knative do for you that you are not do that I wish it did do? So Knative, not too much at the moment. I think it's evolving nicely, and I did use other serverless components. I've used OpenFast originally as well. I replaced OpenFast with Knative because I found Knative more technical, but it resolved a lot of the freedom I needed to do with things. And once I got it right in Knative, it always worked. I didn't have a problem. And with its built-in support with Istio, it just made the rollouts and everything a lot easier to do. But I did have problems with Tekton, which obviously isn't Knative, but it's a roll-off of Knative. And I think it wasn't really a problem with Tekton, it's just a lack of features. And that's why I'm using Argo CD and Tekton in this solution. I've had to basically use two different components that are essentially trying to achieve the same thing, because neither of them do both things that I need.
If you have more questions or comments, also feel free to speak up.
Yeah, and anybody that wants to reach out afterwards as well, feel free to to reach out with any more detailed questions if you want some answers or ideas. I'd say for me, it's opinionated really, but I think it's good to separate. So is it good to separate CI from CD GitOps? I think it is, because CI and CD are two different concepts entirely, and conflating them for me is like conflating C and C++. They're not the same thing, and it just ends up creating a bit of a nightmare. You typically only build something once, and then you deploy it multiple times. So conflating CI and CD into one thing ends up, I think, messing up the pipelines a little bit and creating too many problems in terms of verification, but also in terms of the computation you're doing. So if you're paying for your cloud computation, then you're going to be spending more money because more bills are going to be happening and more deployments. Cool. Yeah, so sorry, does Alex said anything more about the data sovereignty and how farmers are using Edge Mist? The farmers aren't technically savvy, but they are getting, unfortunately, in the solution they have, they're getting ripped off mostly by European markets and American markets because they have dominance in terms of selling. So giving them the tools to actually run their own solution was important, both in cost reduction, but it's also important in order for them to roll out the tools they see fit. When I originally did this, I built my own sensors, and that was prohibitive and also couldn't be used by the farmers. So giving them their own tools meant that I didn't have to pass on any costs, and they could scale as they needed to. So they can roll their own infrastructure, or they can just roll out their own Mist layer. And that's important when most of these farms already have sensors or equipment, and they just want to plug into this solution. So all I have to do is give them some software or give them an API token, and they can roll it out and use it. And then there's cooperatives operating in Africa that they bundle their resources to get a fairer price, and those cooperatives use their own hardware as well, so creating their own sovereignty. And they don't want to share it. Neither the importers, they don't want to share their data because they have a concern that somebody is using it to compete against them. So by not taking their data and actually just taking the intelligence, you're solving all of those issues of competitiveness and custom hardware and custom devices and custom networks. How easy is it to learn Knative? It's really easy compared to trying to learn all of AWS's different components and Azure different components. So I think for me, I push Knative as much as possible, but I'll be honest that it doesn't go as smoothly on any of the projects as I would like it to, because most people I work with already are bought into a specific cloud provider, and they will go with their built-in stack. Yeah, it is easier than AWS because the certification process is so complicated. I think they literally give you a certification process that means you're locked into their solution because you don't ever want to learn anything else again after you've done it. So Knative is a lot easier. Once you've got it rolled out once, it pretty much works in any other Kubernetes deployment as long as the versions are similar. It's things like the proxy configs or the orchestration areas that I think add more complexity than Knative itself. And when you're dealing with things like OpenFast and serverless, they have their own complexities as well, which makes it harder because they don't work as well as Knative does at a lower level or customized level and dealing with serverless stuff. It was the functions as a service I think I found the most difficult getting right, because the serverless works fine, but if you're trying to do a fast product, and again, a lot of the teams I worked with, they couldn't differentiate what the difference was. But if you're trying to do a fast product, I had a few more issues getting Knative to work, but that's purely due to technical complexity. I had more problems with Istio. So any problems with Istio and Knative? I didn't have any problems most of the time that weren't Istio's fault, but that for me was probably due to my lack of understanding on Istio. I did a lot of learning when playing with Istio and playing with Envoy-based proxies. So that's, again, why I've ended up building a lot of WebAssembly custom proxy tunnels now, is because I realized solving them was a programmatic solution, and I didn't want to customize, like put code into the upstream projects at all. I did do that in Kubernetes at one point, and I do regret it. So I instead customizing it with WebAssembly made a lot more sense. Cool. Thank you.
Thank you so much again for presenting. And yeah, amazing presentation. If you are able to share the slides later on, please add a link on the agenda, if that's possible. I think a lot of people would love to revisit them. I think we run out of time today to do breakout rooms as we usually do, but we can do that next time. And you will find these, the recording of this meetup as well as the cut of the demo in the Knative YouTube channel. So thank you everybody for joining us, and I hope to see you next month.